Okay, so let's have a look at linear combinations. Um, Now what I'm going to do is I'll just define what a linear combination is initially, then I'll do a fairly straightforward example, and then an example that's a little bit more detailed of where you might use linear combinations. So let's start with a definition. So if you have two vectors, let's say v1 and v2, they're vectors, and let's say we're talking about R2 here, so two-dimensional plane. Then any vector in the form, let's say alpha times v1 plus beta times v2, where alpha and beta are real numbers. Any vector then in the form alpha times v1 plus beta times v2 is called a linear combination. So it's called a linear combination of v1 and v2. So I'm just talking about the two-dimensional plane here, so R2 here, and we have two vectors v1 and v2. Now if you multiply v1 by some real number and multiply v2 by some real number and add those two products, then the resulting vector is called a linear combination of v1 and v2. So we're multiplying by real numbers here. We're not squaring vectors or multiplying one vector by another. That's why it's called linear, if you like. We're multiplying by a scalar, multiplying v1 by a scalar and v2 by a scalar quantity, and then we're adding the result. So we get a vector that's called a linear combination of v1 and v2. Now I've just used R2 here, so you can use R3, R4, R5. You can use any dimension, any power here you like. So for example, you can use any of these vectors, v1, v2, v3, all the way up to vn. So these will be vectors in any particular dimension, so they can be R2s, R3s, R4s, R5s, but you can use any number of these vectors, multiply them by a scalar and add them, and that will be a linear combination of these vectors. So let's have a look at a simple example where you can use these this idea of linear combination. Let me just move this out of the way here. Don't need that yet. So I'll just move it down a little bit. Okay, so let's take for example v1 being our first vector, and we'll use R2 here. So let's say v1 is 2, 0, for example, and let's take v2 then as being 1, 1. So what we're going to do is do a linear combination of these two vectors. These are in R2 here because you've got, if you like, an x and a y here. So on our Cartesian plane here, on our coordinate diagram here, what we can do is, again, I'll just move this up a little bit. So we have 2, 0 and 1, 1. So let me just take a different color here. So we have 2, 0, so that's going to be out to here. That's that point there. So we're looking at this vector along here, out as far as here. And we also have 1, 1, so we go out 1, we go up 1, so we're looking at this vector here. Let me just do that in a slightly different color. So let's say 1, 1 is going to be here. So we have 2, 0 and 1, 1. So this is v1 and v2. So let's just do a linear combination of these two vectors here. So a linear combination of these two vectors will be in the form alpha times v1 and beta times v2, if you like. So some constant times this here plus some constant times this here. Well, let's take, for example, I don't know, let's say 3 times v1 plus, then we'll take, I don't know, let's say 4 times v2. So what will that look like? Well, it'll be 3 times 2, 0, and then plus 4 times 1, 1. So that should give us 3 2's will give me 6. So our new vector will be 6 plus 4 1's 4. So it'll be 6 plus 4, which is 10. And then 3 times 0, which is 0. 4 times 1, which is 4. So 0 plus 4 is 4. So our linear combination will be 10, 4. So if we look at our diagram here, so what we did here was we multiplied this vector here by 3, so that brought us out to 6, 0. So what we actually ended up with was a vector out to here. Let me just do this in this color. So we ended up out here 6, 0. So this vector went all the way out here when we multiplied it by 3. And then our other vector then we multiplied by 4, so that would be 4, 4. So we went 1, 2, let me see, 1, 2, 3, 4. So we ended up here when we multiplied it by 4. And what we did was we added these two vectors. So we went out along here. We ended up at 10, 4, which is 10 and 4 up to here. So when we added these two vectors, we ended up here at 10, 4. So this is our new vector here. And you can see that if you go out here 6 and then go up 1, 2, 3, 4 along here, so if you add these two vectors here, you will get 10, 4. So a linear combination of these two vectors here that we started with, this was v1, this was v2. So we multiplied this one by 3, this one by 4, and we ended up out here at 10, 4. So that's a fairly straightforward example. So let me take another one. Let's take 3 vectors this time, and we'll call them, let's say, v1 again, and we'll use R3 this time. We'll use the 3-dimensional plane. So let's say 1, 0, 3. Let's take v2 then, another vector in R3. That will be, let's say, 0, 0, 2, 0, let's say. And we'll take another vector v3, and this will be 0, 3, 1. So these are 3 vectors in R3. Now what I'm going to do here is just say, let's say, instead of doing a linear combination of these, let's say we take a particular vector, and let's say see if we can find a linear combination of these 3 vectors that will give us that particular vector. So my new vector, let's just call it v, is going to be 1, 5 and 4. 1, 5, 4. So the vector 1, 5, 4 in R3. What I want to do is see if I can find scalars that I can multiply these 3 by to give me this particular vector here. So in the first example, I just simply made up scalars and I did a linear combination. In this case, I am starting, if you like, with this final vector here, and I want to know, well, what scalars, what real numbers can I multiply these 3 by to give me this vector here? Well, let's say we don't know the 3 vectors, or the 3 scalars I should say, so let's call them let's say alpha, beta, and gamma. So let's say alpha times the first vector. So alpha times 1, 0, 3 plus beta then, let's say, whoops, let's do that in white. So beta then times 0, 2, 0 plus let's take gamma as well, and we'll multiply that by our third vector, which is 0, 3, 1. Now we want to end up with this vector here, 1, 5, 4. So what would these three real numbers here be? So let's see if we can work that out. Okay, well, if you multiply out these, you get alpha times 1. So I'll do these in white at this stage. So you get alpha times 1 plus, or we'll do it the other way around actually. We'll say 1 times alpha plus 0 times beta plus 0 times gamma will give me 1. So this times this plus beta times this plus gamma times this should give me this 1 here. Our second equation then will be the same. 0 times alpha plus 2 times beta plus 3 times gamma should give me 5. And then finally we've got 3 times alpha plus 0 times beta plus 1 times gamma here should give me 4. So let's look at these three equations here. Well, immediately here I can see that alpha is going to be 1 anyway. Alpha here is going to be 1. So that's one result anyway. So let's just write that down here. So this equation here will give me alpha is equal to 1. Now let's see, if I know that alpha is equal to 1, I can go directly down to equation 3 here. So if alpha is equal to 1 here, I get 3 1s times, let's see, I'll just do it underneath here. So you'll get 3 times 1 plus, this is just going to be 0, so this is just going to be gamma here, is equal to 4. So immediately that'll give me 3 1s or 3. Bring this over here, that'll give me gamma here is equal to 1 also. So I've got alpha is equal to 1, I have gamma is equal to 1 as well. So from that here I can just go to equation 2 here, and I can say that I can try and find beta here anyway. So here I can see that I'll end up with 0 times alpha, so I'll have 2 times beta, but that's what we want to find. So it's 2 times beta here plus 3 times gamma, but we know gamma is 1, so it's going to be 3 times 1, and that's just going to give me 5. So that'll give me 2 times beta is equal to 3. Bring the 3 over here, subtract, you get 2 times beta is equal to 2. So that finally gives me beta here is equal to 2 divided by 2, which is 1. So I have alpha is equal to 1, beta is equal to 1, and gamma is equal to 1. Now you may have seen that at the start, so this is a relatively straightforward example, but this is the procedure. This is what you need to do. If you're given the final vector and you want to try and find out what are the scalars you need to multiply each vector by in order to find this final vector. But you can see here 1 will give me 1 here, 0 plus 2 plus 3 will give me 5, 3 plus 1 will give me 4 here. You may have seen that at the beginning, but this is the algebraic, the procedural way, if you like, of finding alpha, beta, and gamma. So in other words, all we've got to do here is our final answer, if you like, would just be 1 times V1, so it's just going to be V1 plus 1 times V2, which is V2, plus 1 times V3, which is V3, and that will give me my V, my final V here, which was 1, 5, 4. So my alpha, beta, and gamma here were just 1. Now let's just take these same three vectors again and add a fourth vector and see if we can find 1, 5, 4 again. So this is going to be a little bit more detailed. So let me just write these down again, or maybe I can just copy these. Let's see if I can copy these. So I need these here. just move down again. See if I can paste them here. Oh yeah, here we go. So these were our three initial vectors, and I'm going to add a fourth vector here. So I'm going to just put in a fourth vector here called v4, and that fourth vector is, let's say, I don't know, 1 2 3. Let's keep it simple. So 1 2 3. Now what I want to do is find a linear combination of these four here that will give me my final vector again. Remember, my final vector was 1 5 4. But this time I want to find a linear combination of these four vectors that will give me this vector here. So it's the same procedure again, but it's not going to be as straightforward. So let's just write down our equations again. So initially we said, well, we're going to say alpha times v1, so that's going to be alpha times 1 0 3, plus then we're going to have beta times v2, so v2 is 0 2 0, and then we're going to have, let's say, gamma again. We'll use gamma times 0 3 1, and let's use, I don't know, let's use delta then, I guess. Delta times our fourth vector then, so it's 1 2 3 here, and we want all of these to add up to 1 5 4. So what constants can we put in here that will give us this vector here? Remember, we're dealing with R3 here. We're dealing with the third dimension, if you like. Now, so you got to write out our equations, solve the equations. Okay, so we're going to take then alpha times 1, so it's going to be 1 times alpha plus 0 times beta plus 0 times gamma plus 1 times delta, and that should give me the 1 there. So we've got 0 times alpha again here, this is these two here, plus 2 times beta plus 2 times beta plus 3 times gamma, 3 times gamma here, plus 2 times delta, and that should give me the 5. And finally then we've got 3 times alpha plus 0 times beta plus 1 times gamma plus 3 times delta, and that should give me the 4. Okay, so we have 3 equations, but we've got 4 unknowns here. So let's just identify these as equations 1, 2, and 3. Let me see, what will we do first? Well, let's just rewrite them slightly because there are a lot of zeros here, so let's see what we can do with those. Well, we've got 1 times alpha, these are going to disappear, and we've got 1 times delta. So what we end up with, equation 1 is just going to be alpha plus delta is equal to 1. That's equation 1. Here we end up with 2 beta plus 3 times gamma plus 2 times delta, and that's equal to 5, and that's equation 2. And finally here we end up with 3 times alpha plus 1 times gamma plus 3 times delta, and that's equal to 4. That's equation 3. Okay, so what I'm going to do then is take equation 1 and multiply it by minus 3. I'm going to take equation 1, multiply it by minus 3. So equation 1 multiplied by minus 3. And I'm going to put that here. So that underneath here. So that will give me minus 3 alpha. And I'm going to get minus 3 delta. Minus 3 delta. And that's going to give me here, this is just going to be minus 3 here. So if I just add these two equations here, so I'm going to add this equation here to this equation here, and you can see that this is going to disappear here, this is going to give me 0 here, and here I'm just going to end up with 1 times gamma. So I can see that gamma here is just going to be equal to 4 minus 3, which is 1. So let me just put a little star next to that. So that's one of my solutions here. Gamma is 1. Okay, so let's have a look at substituting into 2 then. So I'm going to substitute this into 2, equation 2 here. So that will give me, I'll write it over here actually. So I'm going to, I know that gamma is equal to 1, substitute that into 2 here. So I end up with 2 times beta. 2 times beta plus, this is just going to be 1. 3 times 1 is 3. Plus 2 times delta. And that gives me 5. This is equation 2, remember. All I've done is substituted in gamma is equal to 1. So that gives me 2 beta plus 2 delta is equal to 2. So that's just bring this over here if you like and subtract. Okay, so let's just divide across by 2 then. So I'm just going to divide this equation by 2. That gives me beta plus delta is equal to 1. So let's call this equation 4. Okay, so that gives me then beta is equal to 1 minus delta. This is actually a solution. This is as far as we can go with this solution. We're not going to get a real value here if you like. So we're going to effectively get all alpha and beta in terms of delta. And our gamma, this is our gamma here. So this is another solution here. So let's have a look at, we started here with alpha plus delta is equal to 1. This is equation 1 here, so I'm going to bring that down here and do that. So this is equation 1, so we've got alpha plus delta is equal to 1. This is equation 1, so that gives me alpha is equal to 1 minus delta as well. So this is another solution here. So this is another solution here. Okay, now effectively what we end up with here is, let's just write down our final values here. So our final equation, our final solution here. So we have, remember we started with this here. Let me just copy that actually so we can see what we're doing. This is what we started with. Whoops, let me do that again. Let's just copy that down. Okay, so this is what we started with. And these are our solutions here. So we have, let's see, alpha times 103. This is our V1 here. So this is our V1, this is V2, V3, V4, and this is our V. So what we end up with is alpha is 1 minus delta. So what we end up with is 1 minus delta times V1 plus our beta here. Our beta here is also 1 minus delta here. So we've got 1 minus delta here times V2. Our gamma here, our gamma here is our gamma here is equal to 1. So that's just going to be plus V3. And then we've just got delta times, here we've got delta times V4, and that's equal to our V here, which is 154. So that's our V. So this is as far as we can go with this. We're not actually going to get actual values here, but what we can do here is pick any value for delta, and we know alpha and beta. So for example, this is our solution here. So there are many possibilities, an infinite number of possibilities here. So for example, if we pick, let's pick, we'll do some examples here. So if we picked, let's say delta is equal to 0. We'll pick delta is equal to 0. So if delta is equal to 0, look what we get here. 1 minus delta, so that just gives me 1 times v1, or just v1, plus 1 minus 0 here, which is 1 times v2, so that's just v2. So we've got v3, and then here we've got, well, that's 0 times v4, so that's just going to be 0, so we get 1, 5, 4. And if you remember from the first part of this question, this is what we did. We added v1, v2, and v3. Remember, we hadn't got a v4 at that time, so we just added v1, v2, and v3, and that gave us our vector. So we know that works from the previous part of this question. Let's see if we can find more then. Well, let's say delta is equal to 1. If we choose delta is equal to 1, does that work? Well, here we get 1 minus 1, which is 0 times v1. We'll get 0 times v2, so these two are going to disappear. So it's 1 times v3, so we know that v3 then is just going to be there. Delta is equal to 1, so it's v4 here, and that should give me 1, 5, 4 as well. Well, does that actually give me 1, 5, 4? Well, what were v3 and v4? Well, v3 was 0, 3, 1. So v3 was 0, 3, 1. And v4 was 1, 2, 3. 1, 2, 3. And you can see that if you just add v3 and v4, you will get 1, 5, 4. 0 plus 1 is 1, 3 plus 2 is 5, 1 plus 3 is 4, so that does work as well. Let's just do one more, but I think you get the idea there. And there are loads and loads of different possibilities here. Let's just do delta is equal to 2, see what we get. Well, if delta was equal to 2, here we would end up with 1 minus 2, which is minus 1. So we'll end up with minus 1 times v1, minus 1 times v2. We'll end up with v3, that's not affected. And then delta is minus 2, so it's going to be minus 2 times v4. Sorry, delta is equal to 2, I should say, so it's plus 2 times v4. This is 2, so this delta here will be 2. And that should give me 1, 5, 4 as well. Let's see, does that work? Well, our v1, let's see if I still have this. Can I paste it? Yep, I can. So this was my v1 here, so it's minus this here. So let's just do it. Minus 1, minus 0, that's just minus 1. Plus 0, that's fine. And then plus 2 of these, so it's minus 1 plus 2 will give me 1. So that works for the 1 anyway. So you've got minus 0, so that doesn't affect it. You've got minus 1 times 2, so that'll give me minus 2. Minus 2 plus 3, that gives me 1. 1 plus 2 times 2, which is 4, that will give me 5. So that works. And let's try the last one here. We've got minus 1 times 3, so let me just write that down. That's minus 3 here. We've got a 0 here, so that's not going to affect us. We've got plus 1 times 1, which is plus 1. And then we've got 2 times 3 plus 2 times 3, which is 6, plus 6. So that will give me minus 3 plus 1 is minus 2, minus 2 plus 6, which is 4, and we do have a 4 here, so that's perfect. So this is another example. So you can try delta is equal to 3, you can try delta is equal to 4, and so on and so on. You will get different values for alpha, beta, gamma, and delta here. So there are loads of different examples, loads of different possibilities here for linear combinations in order to give you this here with 4 vectors, with these 4 particular vectors here. Okay, so that's it for linear combinations.